Hey, there's probably nobody on yet, but just in case, if you guys could do me a favor, just comment, make sure you guys can hear me. I lost my Rode Link good microphone. I'm super bummed about it. And so I ordered another one, but it's not here yet. So I'm using my AirPods against my better judgment. Looks like there's nobody on yet, so free man. I'm going to show you guys some of the stuff that we're starting to work on the X7. Long time no see. Happy New Year, everybody. Hope you guys are doing well. It's been a heck of a last couple of months for me. A bunch of our guys have been really sick, honestly. Very, very sick. Which major sucks, but I think we're finally starting to come out of it now. I'm digging out material here. We're doing a lot of cutting. All right, let's see here. Let's see what we got here. Hey, guys, I see there's a few of you guys here. It's late on a Saturday. I guess I'll take my baseball hat off just so that you guys can see me. I didn't want to make a super long video today because I know it's Saturday. You guys probably have plenty to do. Behind me is my Silex 7. A lot of the work that I've done on this machine has been for my own business and primarily doing tool and die work. We've really started to this. I've decided that it's probably time to start taking in some job shop work. We don't take in a lot of job shop work around here. We do from time to time. We do small projects, nothing very big. I'm incredibly picky. I don't want to take in stuff that is outside of my machine's capability or anything that's outside of my skill set. And so it's not uncommon for me to turn jobs down. But right now, I have a guy that came in, and it's a project that I've been prototyping on for about a year or so, on and off. I've helped this guy out. And he reached out to me. He said, hey, Jay, would you be willing to... He decided to get some parts cast because it seems to be more effective to have these things cast. Now, you guys probably know that cutting cast iron can be a little bit of a dirty or nasty, messy process. And so I'm going to be careful. But before I started building out sophisticated fixtures for high volume production, we just need to make sure that we can get some of these parts to just fit. We just want to do like a proof of concept. And this is where I truly believe that 3D printing is one of those enabling technologies. It allows you so much flexibility. With that said, you need to be incredibly cautious when you're going to start using plastic fixtures for all intents and purposes. So this one's pretty simple. This is an organic part. You can see there's like an organic piece that goes on here. And so this is literally just like a soft bed. It's softer than the cast iron, so we can set the part on here. We can then clamp it down with a couple of toe clamps. And then up here in the middle, there's a fixture that there's a feature that needs to be flat, and then there's a pocket that needs to be opened up, sized, and then a hole that comes through, and that's it. That's all there is to it. And we've only got like 10 pieces to do. So rather, what I had thought about doing was making this out of aluminum or steel, which we absolutely could have done, but because there's variations in the casting, I think you're just unlikely to have, I think the give that you're going to find in a piece of plastic like this, by the way, this is just PLA right off of your Ender 3 or your Prusa i3 Mark III. So I think this is going to work pretty well. I'll know more here in the next week or so. I need to make sure. I talked to the developer, just one guy. I'm pretty sure he said he's going to call his patent attorney and let me know. If his patent attorney's good with it, I'm going to show you guys everything. I'm going to show you the parts. No blurry, no nothing. I really like the idea of showing you this because it's completely organic, kind of a flowing object with absolutely zero flat spots, nowhere to really fixture this thing up cleanly. So this is the first piece for part number one. Then the other part actually needs to be held at a little bit of a weird angle. And so we designed this. This is actually the first generation of the fixture, and you can see that it's got some V's, some recessed V. And not only is it a V shape, like kind of like a V jaw, but it's also tapered in the Z too. So that you're really just trying to get a few points to kind of capture something. And then the other part that comes down here, we're going to control. This is all eyeball. None of this stuff, none of these castings have been designed with a surface that's actually trustworthy to run as a datum. So this is, we're out here a little bit, all right? This is one of those jobs where I told the guy, I said, look, this is outside of my wheelhouse. And he said that he's been to a few other machine shops and it was way outside of their wheelhouse too. Nobody even wanted to touch it. So I told him, I said, listen, I'll do my very best for you. We're gonna try this real quick. If this is something that works well, there are a lot of things we could do to make this more efficient. Instead of having this bolted, we could put this front part on a hinge so that it just opens up and then it has a clamp. So it'd be a lot faster changeover. Same thing with toe clamping the pieces. Maybe even putting in some fixtures that help kind of keep it more closely aligned. We took all of the cast pieces that are going to go in this fixture and we labeled one as a master, and then we took 6 main dimensions off of each part and we made a spreadsheet just to see what kind of variances we were dealing with. And for the most part, we weren't the worst tolerance on a part the size about this big here, about the size of your fist, was about 1 millimeter. So pretty reasonable. And this is not, it's a functional part, but the tolerances are 1 millimeter is fine. So those are the two things that we're going to do. And the one thing I probably will end up doing here is I'm probably going to take the rotary back off the X7. The vast majority of the work that I have done on this thing has generally been mold cavities. And I'm going to show you guys the type of work. I don't have one that was made on the machine right now because they're actually in our presses, but I'll show you an example here. This would be like a B-side, but something like this. This is tool steel. It's got datums in it with hardened bushings. It's got hardened bushings. This is P20 tool steel. Not super hard stuff, but I have made quite a few of these along with other larger mold bases. And so the job shop works a little bit outside of my wheelhouse, but I'm excited to do it. Yeah. Most of the jobs that we've done this, like I said, we haven't been able to share, but I'm really excited to do more. I keep seeing more and more guys on the Sile Facebook group that are doing like cool knives. They're doing all kinds of cool stuff. There's some comments here and I'm going to read these to you guys. Do I have any issues with tolerances using the 3D printed part? And also, does PA hold up with coolant? Brian, to be completely fair, I've only done this one other time and I only made one part, so it really didn't make a big difference. Keenan Barker is saying that I have found that some of the coolants eat up PLA way more than others. Still not exactly sure what ingredient it is that causes it. Keep in mind, coolant will always try to find a way into any holes. Yeah, just so you know, both of those are printed completely solid. That doesn't mean they're not porous. We both know that FDM models a lot of times are quite porous. But those are both printed completely solid for that reason. Make no mistake about it, you guys. I think that printing fixtures is an incredibly useful tool when you want to make a couple of parts or if you're trying to prove out a concept. If we end up being able to hold our parts with a printed fixture, this one, so one of the guys from the shop, when he actually drew this up, I don't know if you noticed, but there's a shear force. It's actually going to torque the part because this thing we're supposed to match exactly edge to edge, and he kind of got caught slipping. He kind of got in a rush, and so this piece slips underneath this upper piece. I think the lesson here is if this works, if this design works with reduced feeds and speeds, we're probably going to limit the size of our end mill to maximum 1/4 of an inch. If this works, then I'll make one out of steel or aluminum. right away, and we'll be rocking and rolling from there. If this works, I will very likely tool up a plate, like a fixture plate, like a pallet for the Pearson pallet system here in the X7 that has probably four of those is my guess. Maybe two in the front, two in the back, with a swing door. That way they can clamp shut. And just so you know, something to keep in mind: if we were going to, instead of clamping this piece in here like this, if we just put a hinge right here, let's just say we put a hinge right here, we could then extend this out a little bit longer. That way, if we use like a little clamp, kind of like the clamp that's on the vacuum former, I'll show you here in just a few seconds. If we used a clamp similar to what's on the vacuum former, as long as we had a little bit more distance out here, we'd have plenty of leverage, so we'd have plenty of holding force. And so I'll show you guys what I'm talking about real quick here. Let me turn this around. Just going to walk you guys over here. So these clamps right here, stuff like this right here, works great. This, when this is up, this thing can come apart. When it comes down, you can just lock it down, and these can be adjusted for fit. And so that's that. The other thing that we're going to be working on quite a bit with the X7 is some plastic injection molding parts. So I'm going to show you guys those right now. It's when you start making parts for injection molding, especially when the tolerances are tight and you need things that shut off nice and clean, it's important that you trust your machine. I can't stress that to you guys enough. If you guys don't trust the machine, or the machine will not cut nice, accurate features with, flat surfaces. So this is a mold that I got from somewhere else. Unfortunately, when they sent it to me, it was so bad that it ended up looking. So this was one slide, which wasn't too bad. And then look at this one. Look at the destruction. Look at how destroyed that is. This is the way it came. And so I ended up making one that I don't even think you can compare. Just so much cleaner and neater. And so that is something that I will share with you guys over time as we get to doing some of the manufacturing for that stuff. I'll try and show you the machine real quick. People have been asking quite a bit about the machine. And so that I thought I would show you. Real briefly, we've got all the sheet metal off of it, but this is just a little benchtop. I would call it an injection molding machine, but the truth is it's more of an extrusion molding machine because there is no plunge down here. This just spins to inject the plastic into the mold itself. It does have, it is able to run like a true ejection cycle, and there are options for infrared drop sensors, which we have to kind of automate this. This was something for incredibly low production run plastic parts that we have, that we kind of prototype and tinker with. Rather than drawing up something, having Taiwan make a $5,000 mold or a $3,000 mold, this is something that we can grab a chunk of aluminum, make a small mold, mount it in here, and then run a relatively small number of pieces, right? It's 3D printing is cool for some stuff, but there are times when you either need the durability or the accuracy that injection molding offers. And so we've actually had, we've done quite a bit of experimenting with this with a variety of different plastic materials, and specifically high durability nylons. And I can tell you, they are absolutely not created equal. In some of our molds, we have no problem ejecting one material, and then the next material, the ejector pins just pop right through it, and it's just an absolute disaster getting the parts out of the mold itself. So we'll be covering more and more of that stuff as we move forward here in the next couple of weeks. So many guys, the boys have just been, literally every person in our shop has been sick, like not just a little sick, but really sick here over the last, I'd say, 3-4 weeks. I mean, two of our guys that work in the back were both out for a week each. Our vacuum tooling guy was out for a week. Our shipping guy's been out for 2 solid weeks. It's been pretty gnarly. So we have here. Just so you know, I'm going to bring this up. There was a question that I just saw. It said it was from El Baus. It says a pair of 3D printed jaws are able to hold a part while roughing on a machine like the Haas TM2. The short answer is maybe. I would say depending on the part, depending on the tool path, depending on the programmed feeds and speeds, it's not impossible to use 3D printed parts. I want to say something. I have heard this over and over, and sometimes I've never pretended to be the best machinist in the world, the best tool and die guy in the world. I'm not. I'm absolutely not. I know I'm not. I have learned, I've developed the skills to make the products that are important to our business. So I'll answer the CNC question in just a second here. Whenever I hear someone say, "Oh, my machines only cut plastic," or you can crash a CNC machine on a piece of HDPE just as easily as you can on a piece of aluminum. If you wrap that machine in Z straight down onto a piece of HDPE, that's just like crashing aluminum. No difference. You can murder ball screws, misalign the machine, injure the spindle, destroy the bearings, whatever. The real trick, if you're going to start doing things like using glue or tape or plastic fixturing, it's really about managing the tool load. Would I ever try to fixture something in a tool like this and get after it with, I don't know, this 1/2 inch 7 flute end mill? No, I wouldn't do that. The force that's going to be imparted onto a machine with a tool like this that has this many flutes on the cut, that has this much diameter, I just wouldn't trust it. But could you do it with, I don't know, this little fella? Yeah, I think all day long you could get away with this. And why? Because you're not putting nearly as much pressure onto the part as you take your cut, right? So let me answer a couple more questions. This is already 19 minutes. I can't believe how long this slide video is gone. I didn't intend for it to be that long. Let's see here. I'd love to see a walkthrough of rigid tapping on your XM. Dan, I can absolutely do that. In fact, there's a video here just recently, just a few videos back, where I made a part for my buddy. I had to trim down a hex, and I wanted to do it as accurately as I can, and I rigid tapped it. It's just using good old-fashioned rigid tapping, and it's right inside Fusion 360. If you're worried about it, take the tool out of the machine and let it run, and you'll see if it kind of looks coordinated. Another little trick is that when you want a rigid tap, I don't have a vise in this machine, so let me turn it around and I'll show you inside here. What you can do here is you can take your part. Let's see if I got it. Let me grab a part. What you can do is you can put your part in here, and when you're ready to rigid tap, you can just ever so slightly back this off. That way, keep in mind, you want to go a little bit slower, but when the machine comes down, if it's wrong, it'll probably break the tap on the way in. Or when it comes up, it can just pull the part out of the vise. So you obviously don't want to try this when you're tapping at 2,000 RPMs. But if you're tapping at a few 500 RPMs, if the thing starts to come up, you can hit the e-stop or feed hold the machine real quick, and you won't have to worry about it. You're not going to rip the tool holder out of the spindle or anything like that. But yeah, it's pretty straightforward. And what machines are in my shop? We have the X7 you guys just saw, our 3DM, a little VM2, and then we have our Akuma M560, little Tormach lathe, and then up front we have a small surface grinder that's in the front of front of the shop because it's just a little bit dirty. So let me do this here. That's that. All right. Well, we've been out here for 20 minutes. I honestly just wanted to show you guys. I haven't really made too many videos using the X7 lately because everybody's been out sick. So I've been brushing up on my shipping and my packaging skills, kind of running Overwatch for the business. I haven't been out here in the machine shop literally at all. Tonight's really one of the first nights that I've been out here spending a bunch of time making electrodes so that we can burn the features into one of our new molds that hopefully will get done later. Yeah, because so we have some customers that brought us a small Darwin parts, and it's always a nightmare to grab them, but they don't need to be precise. Yeah, it's tough. It's a little tricky. We don't actually run. Alex, you're asking questions. We actually make molds, and so none of these machines cut anything that gets sold. We make molds. Simple as that. And well, to be fair, the very exceptional, rare job shop work is almost exclusively under non-disclosure agreements. I wish I could show more of this to you guys, but you know how it is. Most guys that are actually making stuff, they don't want the world seeing how it's made. They don't want to give their competitors an advantage. The tool and die work that we do, it's nothing super special. It's just cutting features, making electrodes, burning in features with the EDM machine that can't be cut, put into the part with a spinning cutter. What 3D printers? We have a whole bunch of 3D printers. We have a bunch of mainly low end stuff. We have a couple of I have like 3 or 4 Prusa i3s. We have a couple of Ender 3 version 2s, Ender 5 Plus. We have a small Elegoo Saturn, the MSLA resin printer, which we barely use. And then we have our newest, biggest, baddest mamma jamma is actually our rat rig. We have a rat rig V-Core 3.1, which is the 400 millimeter cubic version. And it's honestly awesome. I wish you could buy those things assembled because in businesses like ours, you really don't want to invest the time. I paid one of the guys that works here, I'd say about 45 hours to build the rat rig. And it's fast, it's unique. It's fast. It's been medium reliable. But for the money, I really don't think there are too many better options out there. So, all right. Well, it's been 23 minutes. If you guys have any questions, I will do my very best to answer them. And if not, then I guess we'll cut this thing short. I literally just pulled the fixturing out of here, so the table's all nice and neat. So I need to get these printed fixtures back in here so we can get the mix apart. Any advice for finding job shop work? I can be honest. I'll be straight with you. I'm not the king of job shop work. I can tell you this. I truly believe in my heart that there's a lot of people out there. I talk to people all the time that go looking. The guy that's asking me to make these parts that I showed, these printed fixtures, he's been all over the place. And so many companies are just incredibly reluctant to help, to actually solve the problem. And I will tell you this. If you're looking for job shop work, stop worrying about dollars per hour. I could literally go on an hour-long rant about the idea of dollars per hour. I'm not going to do it here. You don't pay for your car in dollars per hour. You don't pay for your mortgage in dollars per hour. You don't pay for anything that you buy in dollars per hour. You just pay for it in good old-fashioned dollars. So when I hear these arguments about guys that are talking about, I won't do this for this many dollars per hour, I won't do that for this many dollars per hour, I think there is something to be said for building relationships with customers. And if someone comes in and they're in an absolute jam and you help them out and you're fair with them, I believe that in the future, they will look forward to repaying that favor. I think more often than not, you could trick a guy once, maybe even twice, but the ultimate solution to generating and growing a business is just doing good work, making a promise and keeping that promise. And when you can't, just be honest. Don't BS them. Don't slough them to the side. Communicate, be honest, and do your very best. If it's something you can't do, don't take the job. I've had a few people reach out to me. They took that have asked this kind of question before, and they've got it over their head. They get all giddy at the idea of a company. I actually just had a company that makes hypercars reach out to me here recently. I've seen guys get all giddy and take jobs that are in over their head, and then when they either can't get it done or can't get it done on schedule or their equipment's not capable, it's just a disaster. So I would say go out to all the engineering firms in your town, go out to all the manufacturing, go out to the production. There's always guys there. Even though we have all these machines in this shop, there are plenty of parts that I would love to have somebody else make for me. And if they're slow and they could do it for a price that's reasonable to me, I would do it in an absolute heartbeat. So, all right, guys, I don't want to stand here too long. It says, better to not work. Is better not to work dollar for hour. We have an amazing relationship with our customers. They always come back. Yeah, Dan, I would like to get the Pioneer probe set up. Is it over here? It's just in the cart behind us. Yeah, I need to get that set up. You know, this machine, you guys probably don't know this, but there was a lot of testing done on this X7 by the guys at Syntec America. And so my machine's a little, it's kind of, it's not as nice and neat and clean and organized behind the scenes as a brand new machine would be, because we've just done so many changes and tinkered with it so much. So they actually tried installing probing on this a while back, and like the ladder logic had been modified, and so it's kind of a test mule. It's kind of a test rig. It works. It makes great parts, and I love this machine, but it's not as uniform in its software as a lot of the other machines that are now coming out of the factory today. So, all right, guys, that's it. Thanks for hanging out with me. I appreciate it. Stay tuned. We're going to be making more content. I ordered a new mic. I'm actually really excited to get back to making more and more content. This whole process getting into the new year has just been a little overwhelming because of the guys being sick and a bunch of other things going on with the business. But I enjoy making content. I love talking to you guys. I love challenges. I love tinkering. And more than anything, I love cutting metal, So that's it. If you guys like this, do me a favor, click the thumbs up, share this video, and we'll see you guys real soon. Bye-bye.